Question 25. Kelly conducted an experiment on springs A and B. She hung various loads one at a time and recorded the length of the spring. So we can see spring A, which is represented by a solid line, and spring B is a dotted line. So pay attention to the load that is attached, which is found on the horizontal axis, and the length of the spring, which is the result that we are measuring, found on the left. So we can see that at no weight, at 0 grams, what is the length of spring A? So spring A, we can see, is 10 cm. And for spring B, when no load was attached, what was the length? The length was 20 cm. So hence, what is the extension of the spring? So the extension of the spring, if a load was attached to it, we will take, for example, let's say 40 grams. Okay, and for 40 grams, what is the extension for spring A? You will take the answer here, which is 50 grams, 50 cm rather, minus 10 cm, the extension is 40 cm. For the question A, what is the extension of the spring? Extension means the length that is increased as the weight was attached. So if for 40 grams, what is the extension for spring A? So the answer is 50 cm for spring A. How do you get 50? Sorry, the answer is not 50, it's 50 minus the length of spring A, which is 40 cm. What about spring B? Spring B at 40 grams, the length of the spring is 40. But when we minus the original length of spring B at 0 grams, the answer is 40 minus 20, you get 20 cm. So when a load of 40 grams was attached, the extension of the spring, you have to minus the original length of the spring. Let's look at part B. Which spring can stretch better? Give a reason for the answer. So at 40 grams, you can see that spring A can stretch better than spring B. But let's look at another answer here. Okay, is at 80 grams. What is the extension of spring A? So spring A at 80 grams would be 90 minus original 10 will be 80 grams. Whereas for spring B at 80 grams weight, the extension of the spring is the length, which is 60, minus the original length, which is 20, will give you only 40 cm. So definitely spring A can extend more than spring B. So spring A extends or can stretch better than spring B because the extension of spring A is greater than spring B with the same load of, let's say, 80 grams. So how can Kelly conclude about when she compared the effects of the different weights on spring A. So the answer for part C is that for the heavier load, the extension on spring A is greater than that of spring B. So we can say that the heavier the load, the longer the extension of the spring A. That's the answer.